Hi there, my name is Sam Gorle and I am a civil engineering student from CQUniversity, Rockhampton, and today my presentation is on safety factors. Safety factors, also known as factors of safety, are numbers that describe the structural capacity of a system or structure beyond the loads that are expected for it to experience. In other words, they describe how much more stronger something is compared to what it needs to be in order to satisfy its intended application. Engineers use safety factors both during and after the design stage of many different projects, as they help provide a standardized way for comparing strength and reliability between systems. To most people's surprise, there are actually two types or definitions of what a factor of safety is. The first is the ratio of the absolute strength and structural capacity of a system to the actual loads being applied to it. This specifically provides a measurement of the reliability of a system or a particular component within a system. This factor of safety value should be referred to as a realized factor of safety. The second definition is a constant that is imposed upon a system or a component by design standards, codes, regulations, and/or laws. A particular design must conform to or exceed the required factor of safety. These constants should be referred to as a design factor or a required factor of safety. Now, these two definitions may sound very similar to you. However, knowing the difference is important, especially when talking about factors of safety to other engineers and stakeholders. It is often the case that which factor of safety is being referred to is not specified. Therefore, special attention must be taken in these situations. The calculation and inclusion of a safety factor during the design steps of a project is very important. The realized factor of safety of a completed design is easily calculated by dividing the strength of a particular structure or component by the design load, where the design load is the maximum load that the structure or component should ever experience within its design lifetime. If a particular safety factor needs to be applied to a design that is a work in progress, it is as simple as rearranging the equation so that the strength can be determined by multiplying the design load by the necessary safety factor. Design factors, however, do not need to be calculated, as they are specifically provided by the project requirements or standards relating to the particular situation. I would like to put these two different factors of safety into context with an example. Let's say a single column for a particular structure is required to have, in accordance with Australian standards, a design safety factor of 4. After analysis and design, the engineer working on the project chose a column that provided a factor of safety of 10. This means that the column can withstand a load 10 times greater than the largest load it should ever experience within its design life. Despite this, the design factor of safety in that column is still 4. This is because the design factor is just the requirement that needs to be satisfied by the engineer who is designing the column. And the column in this situation just happens to exceed the requirement with the safety factor of 10. In saying this, the calculated realized factor of safety should always meet or exceed the specified design factor. If it doesn't, then the proposed design is considered not adequate for the particular application. Here are some other things to consider when talking about factors of safety and how they influence your design justifications. A safety factor that is equal to the required design factor implies that the design is quite literally as weak as it possibly can be, while still satisfying the allowable minimum strength. On the other hand, safety factors that well and beyond exceed the design factor implies over-engineering, which can result in excessive weights and/or costs. Due to the potential of this occurring, there is a somewhat universal push towards conservatism, especially with the inclusion of safety factors. This occurs at times in particular when there is an absence of highly detailed and accurate data. New or inexperienced engineers can sometimes push the boundaries between a sustainable design and a weak design, which can result in devastating consequences that are not worth the risk compared to the relatively small savings made. The use of a safety factor does not immediately result in a design as being safe, as other aspects affect the safety of a product. Quality assurance, manufacturing and installation processes, and engineering design processes all may influence the overall safety of something in any particular situation. Engineers all around the world are designing everything from cars to buildings to airplanes, and they all consider safety at some stage throughout the design process. And fundamental to all safe designs is the inclusion of safety factors to make sure that the design satisfies the requirements and exceeds the required strength needed to survive the loads it will experience.